Hello everyone, welcome back to Mrs. Torres' YouTube channel. Today we are going to start chapter 6, which is all about quadrilaterals. Before we get into quadrilaterals, we got to kind of take a step back and talk about something else first. So we're going to talk about a plane figure that is formed by 3 or more segments. So here's an example of one. That is called a polygon. And the segments that make up the shape are called sides. So an example of a side in this polygon here, we could say SU. A polygon is called a regular polygon if all sides are congruent and all angles are congruent. If you think back to past chapters, one example of a regular polygon that we talked about already is an equilateral triangle. In a polygon, each side intersects exactly 2 other sides at the endpoints. So here's an endpoint, here's an endpoint, here's an endpoint. There's actually 5 of them, right, where the sides intersect. And these are called the vertex, or plural vertices. So an example of a vertex in this shape would be S. It's really any of the letters is your vertex. 2 vertices that are endpoints of the same side are called consecutive vertices. That really just means next to. So one example would be R and E. Those are consecutive vertices. They're next to each other. A segment that joins 2 non-consecutive vertices is called a diagonal. And if you want to draw that up here, one example would be from S to E. Now, of course, there's other ones. That's just one example of a diagonal there. All right, and the last 2 bullet points here. A polygon is concave if at least one extended side passes through the interior of the shape. So I'm going to draw an example over here. So at least one extended side passes through the interior. So if I have a shape looks like this. This is a polygon, right? We have 3 or more line segments that make up this shape. If I were to extend the sides, okay, there's nothing on the interior there, so that one's good. What about this one? Extend them, just draw dotted lines. That one's in the clear too, nothing on the inside. But if we, if we extend this one, notice how it goes through the interior. So we would call this a concave polygon. The way that I remember the difference between concave and convex is, say we have a cliff. If there's a cave in your cliff, it's going to go in, right? So here's a cave, a little person there. That goes in. Same thing with a concave polygon. There's going to be some sort of indent there to make it concave. And then kind of the opposite of concave, if it's convex, that means none of the extended sides pass through the interior. I'm going to draw this one up here. So if I draw a shape that looks like this, let's extend our sides. Okay, nothing on the interior. Nothing on the interior. Nothing on the interior. Nothing on the interior. So none of the extended sides pass through the interior. So we would call this convex. All right, go ahead and pause the video. Take a look at numbers 1, 2, 3. Tell me if they are a polygon. If it's not a polygon, give me a little explanation as to why. So go ahead and pause the video and do that. All right, welcome back. Let's take a look at these. Is this a polygon? Is it a figure, a plane figure formed by 3 or more segments? Yes. Does each side intersect exactly 2 other sides at the endpoints? I would say yes. That is a polygon. Look at number 2. We have a figure formed by line segments. Yes. Does each side intersect exactly 2 other sides? Now the key there is exactly 2 other sides. Let's focus on this side for right now. So it intersects this side up here. It intersects this side down here. But notice it also intersects there. So that right there makes it not a polygon because it must intersect exactly 2 other sides. Can't be less, can't be more. It has to be exactly 2. And number 3, is this a plane figure that's formed by 3 or more line segments? Well, line segments cannot be curved like this. So no, must be line segments. No curves in polygons. All right, go ahead and flip it on over. All right, classifying polygons. We're going to classify by its size. So how many sides does a triangle have? We know that's 3 sides. We all know what a triangle looks like. Quadrilateral, that is going to be the focus of this unit, or chapter I should say. That is 4 sides. Quad means 4 sides. Now, a lot of us probably thought of a square or a rectangle. Those are good examples of a quadrilateral, but it could look something like this as well. Pentagon, we've got 5 sides. There we go. Hexagon and heptagon, I mix up a lot. A way that I figured out to remember the difference between them is hexagon has 6 sides, and both of those words have an X in it. So 6 sides for a hexagon. Heptagon is 7. Seven sides. And then last but not least, octagon is 8 sides. And a lot of times we will see stop signs, and those are octagons. All right, go ahead and pause the video again and do numbers 1, 2, 3. And when you come back, we will go over them. All right, welcome back. So first, 1 and 2 we're going to classify as concave or convex. If you don't want to extend all the sides, just look and see if there's an indent. Notice right here, there's an indent. So if I were to extend this side and extend this side, it goes through the middle there. So we call that concave. Remember, if it's an indent, it's concave. This one, there's no indents. This would be convex. And if you want to, you can extend all the sides and make sure that nothing goes through the interior. That is fine. All right, last one. The figure below is a regular pentagon. First of all, pentagon is 5 sides. What does regular mean? We got to think back to our vocab. Regular means all the sides are equal. So if the side A is 5 feet, and this is a regular pentagon, that means all the sides are going to be 5 feet. And then we've got to remember how to find perimeter. You just add up all around the outside. So 5 plus 5 plus 5 plus 5 plus 5 will give you 25 feet. Don't forget to put units when you're looking for perimeter or area or anything like that. All right, see you in my next video.